Okay, I want to go back to division and talk about some gotchas and some caveats, if you would, about the divide instruction. You remember we did 9 divided by 2, and that put 4 in the accumulator register, and it put the remainder of 1 in the data register. But I also kind of hand-waved myself, and I didn't tell you about something I probably should have told you about. When we do the division, remember with multiplication, it stores the result in the EDX EAX pair. And when we do division, it's assuming that we're going to divide the EDX EAX pair by the divisor, okay, 2 in this case. Now, I didn't really point this out in the last video, but if I hit F11 here, and I hit Control-D and F11, and, well, I moved 9 into EAX, so EAX became a 9, and then I moved 2 into EBX, and EBX became a 2, but I didn't really point out with the data register, it's already set to 0. Alright, but if this wasn't 0, then my divide would say divide these 32 bits followed by these 32 bits, making a 64-bit number. Divide that big number by whatever values in EBX. Okay, and so divide kind of does that. It kind of works opposite of multiply. If you think about it, multiply it, it'll multiply the values, and if it overflows, it'll overflow into EDX. But divide says, well, okay, go ahead and divide, but we'll consider it division of EDX combined with EAX. So it's important that if you want to do a divide, that your EDX values are set to 0. Right? Let me just prove that here. Let me go back and let's move into EDX. I'm just going to move EDX. Let's put a 1 out there. Just turn on 1 itty bitty, the first bit in EDX. Okay, and then we're going to do the divide by 2. And will the result still be 4? Pause the video and think about it. I'm hoping that the answer is obvious, but maybe it might not be. Control-Alt-D, F11, EAX, let's change that to a 9. EBX, let's change that to a 2. EDX, ooh, no zeros. We're going to put a 1 that just one itty bitty bit. Okay, and then we're going to divide EAX by EBX. What will the result be in EAX? 8,0,0,0,0,4 hex. Okay, that was a huge number. Now notice we still have the remainder of 1 hanging out in EDX because we divided an odd number by 2, which will always give us a remainder of 1. But then EAX is much bigger because the value we divided, the EDX EAX pair, if I put it here, it's basically 0, 0, 0, 0, 0, 0, 0, 1, and then these were all zeros. And these are all 0. Or wait, no. They were, let's see, we had a 9. What's a, oh, we're doing hex. Sorry, it's getting late. 0, 9. Okay, so instead of having $9 in our bank account, we had 1 followed by all these zeros and a 9. That's nice if you think of this in terms of your bank account. Just turning on this one itty bitty bit off in the upper 32 bits it's a big deal. Okay, that changes our result dramatically. In fact, let me prove that with the Windows calculator here. I'm actually going to go, let's go to binary mode. So now I can just put 1s and 0s in here. This should be familiar from the binary numbers playlist. So to do the equivalent of what we did here with having this 1 bit turned on and then the rest of these be a 9, on the Windows calculator I have to turn this 1 bit here. This needs to be a 1. And then the 9 needs to be stored in this lower nibble. So that will be 1, 0, 0, 1. So let me see if I can figure that out. I'm going to go to binary mode and go 1. And then push this. You see this 1 bit, how I'm pushing them all the way over here? Like so. All the way to right here. So he's right here. And now I'm going to drop the 9 in, which is 1, 0, 0, 1. So now I have this bit turned to a 1. And then the 9's here. Let's divide, there's divide. Divide that by 2, which is a 1, 0. And then watch what happens. Pop. Look, we have an 8 here, zeros here, and then a 4 here, which is the same as what we have here. 8, all zeros, and 4. Okay, and you could do the decimal conversion if you wanted to. Anyway, So EDX, EAX, when we do a divide, we're dividing the EDX, EAX pair. The result is stored in EAX, the remainder is stored in EDX. Now, what if I have a number and that is too big? Well, say I have a really big number and I divide it, but the number is, the answer is still greater than 32 bits. It's too big to fit in EAX. You might think, well, just shove the extra in EDX. Well, I can't shove the extra in EDX because EDX holds the remainder. What happens? What do you think will happen? Let's try it. Shift F5, get out of the debugger, go to our code file here, and let's stick a really big number in there. So 0x 1, 2, 3, 4, 5, 6, 7, 8 hex. Okay, and then in EDX, let's put EDX here. EDX, I'm going to go 0x FFFFFFFH. All right, so I'm taking the biggest possible 64-bit value, stuffing it in the EAX EDX pair, and then I'm going to divide that by 2. And let's watch what happens. I think we're done with this. Let me clear this off. We know the results will be too big for a 32-bit register. Let's see what happens. What's this? Missing operator in expression. Oh, I'm typing hex as hex. I don't need to prefix it with 0x. We suffix it with h to represent hex, but I do need a leading 0 out so the parser knows what to do with it. F11, Control-D, F11, 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 F11. Here's our divide. Here's our registers. Notice the EDX, EAX pair is huge. Divided by 2. Oh, integer overflow. It's basically this is a flag got set, basically saying, hey, I can't stick the result anywhere. It's too big. So even though that's kind of nice, we can take the EDX, EAX pair and do a divide. The answer or the result must be less than 32 bits.